Okay, we are in Unit 7.7, Financial Models. We're going to be talking quite a bit about interest rates and interest and how that works. You have this first one, which is called simple interest. Not the most used when it comes to this mathematical stuff that we're doing. The simple interest formula will really be good for us to at least start defining what these things mean. It's I equals P times R times T. I stands for the interest. It is the amount of interest. P stands for the principal. I always have to think about how to spell this one. I think it's principal, which is basically the amount of investment. It's the initial amount of money that you're putting into something. R is the interest rate. And it will be given as a decimal. Must be expressed as a decimal, so not a percent. Your interest rate is 5%. Don't write it as 5. It's going to be 0.05. That's how you get an interest rate. So 5%. To change a percent into a decimal, you simply divide it by 100. And then T is the time. And that basically tells you the amount of time that you are going to allow something to sit to accumulate its interest. For purposes of the vocabulary here, most of this hopefully makes sense. If I say that it's going to be something where the time is daily, that means 365 times per year. If I say that it's going to be monthly, it's 12 times per year. Quarterly, 4 times per year. Semi-annually, basically twice per year, and then annually is once per year. A little bit of vocabulary there just to make sure that you're okay with that. So if we wanted to compute some simple interest, as long as you know the principal, the rate, and the time, you just plug them in. If you actually wanted to figure out how much time it took you to accumulate a certain interest, you would have to know the interest, the principal, and the rate, and then you would just solve that for T. Or you could figure out the rate, or you could figure out the principal that was there. Given the other 3 variables, this is a really easy one to use. Again, it's not the most common. I'm really not going to go through an example because I think you all can figure that part out pretty easily. You literally just have to do one step to solve for whatever missing variable it is that you have. You do have to be given the other 3. That's important. A more common one that we're going to use is what's called the compound interest formula. Compound interest formula. Okay, this one is very common. So the compound interest formula is A equals P times, in parentheses, 1 plus R over N, and the parentheses, all raised to the N times T power. Okay, so we've introduced another variable here that we haven't had to deal with before. The N stands for the number of times per year. So that's where the whole vocabulary comes into play. Semi-annually, annually, daily, monthly, whatever. That's what that represents. The N is the number of times per year. So N is the number of times per year. For example, if I wanted something to be compounded quarterly, N would be 4. It basically means that every 3 months they would calculate how much interest or how much I actually don't know what the A stands for, to be honest with you. I've been using it for years. It's just the amount A. It's not annuity or anything like that, I don't think. So I think it just represents the amount of money that you have because you're not actually calculating the interest here. You're actually calculating how much money you have based upon a compound interest formula. We'll do an example, and then hopefully it'll make some sense. I'm not sure exactly what A stands for. I always just call it the amount. Hopefully that's acceptable mathematically. All right, so for our example, we are going to be given the principal is $1,000. We are going to be told that our rate is 0.02. So that's the same as 2%. We just don't have to convert it because they gave it to us as a decimal. And we're going to be told that N is 4. And T here is just going to be 1. So let's decipher what the information means, and then we're going to figure out what the A value is based upon this information. So the principal, again, $1,000, that's the amount that we're starting with. We're investing $1,000. So we'll put the 1,000 in for P. The 1 is always 1. The interest rate is 0.02, which really means 2%. The N tells us that we are doing this quarterly, 4 times per year. And then we're going to raise this to the N, which is 4, times T, which is 1. So now we can actually figure out how much money we would make if we invested $1,000 and they recalculated the amount of money based upon a 2% interest rate 4 times per year. Because what happens is after 3 months, they calculate how much you have. You'll then have a new value, because you're actually going to make some money based upon 2% of $1,000 after 3 months. So that new amount basically becomes your new principal. This formula takes care of doing all that. You don't have to say, okay, now I have $1,002. Now I have to redo it again using simple interest. Now I have $4.50 or something like that, whatever it comes out to be. So this formula takes care of all of that. From here, it's literally just plugging stuff into a calculator. You just have to be careful. Personally, I like to do what's inside the parentheses first. I do 1 plus 0.02 divided by 4 in the calculator, get a value, raise that to the exponent, which in this case is going to be 4, and then I'll multiply it by 1,000 at the end. That's the way I actually like to type it into the calculator. However it works for you, as long as you're getting the right thing. What I will tell you is usually that is the hardest part. It's typing the stuff in the calculator the right way to get the value. Once you plug all this in, so if we compound this interest 4 times per year or quarterly, it says that at the end of 1 year, I will now have $1,020.15 approximately. Remember that you're dealing with money, so any decimals after the second decimal, just round that second decimal as appropriate. All right, and we're not going to run through all the examples, but if we took this exact same scenario and instead of compounding it quarterly, I said, well, let's compound it monthly because that's going to be more compounding. If we did it doing that, so you would plug in 12 for your N value, that would actually give you a slightly more A value or return at the end of the 1 year. If you were to compound it daily, 365 would be your N value. So this thing right here would be 365, and so would that one right there. It's going to be a slightly bigger A value at the end of 1 year. The concept is the more you compound this stuff, the more frequently you're reacquiring your values, the more money you're going to make. It's not a huge difference over a short period of time, but over a very long period of time, it can add up quite a bit. When we compound something more than daily, I mean, you can actually break it down to half days if we really wanted to, and just change the bottom number to whatever 2 times 365 is, 830 or something, or 730 or something like that. But that's not the point of that. There's another formula. Again, I am making this stuff really short because I think it's pretty easy overall, just plugging stuff in. there is a formula where you can compound stuff continuously, which means basically every second of every day it's recalculating and compounding. Now, it's not going to be a huge difference. You would think it might be because it's compounding all the time. But the amount that you make when you compound something so quickly is really, really small, but it does add up to be a slightly bigger amount. So the second formula is A equals P times E to the RT power. So the E, the exponential equation E to the RT power, is basically the thing that compounds stuff continuously. So this would be a continuous compound. Okay, but pretty much every second of every day, it's just continuously going to keep compounding the interest. Okay, this one is a very common formula, and this is primarily what you're going to use when you get to upper level math as well, in order to, well, you'll see because we're actually going to do some examples in the next section, but this has a lot of practical applications to real life scenarios that people use. So let's see, our example here is we are given, once again, the principal is going to be $1,000. We're going to be given, whoops, whoa, what happened there? Sorry. We are going to be given the interest rate is 3%. And it will be annual. And we're going to do this over 12 years to see how much money we would return if we had an initial amount of $1,000 at a 3% rate for 12 years. What would be our amount that we get back? Well, let's figure it out. The principal is $1,000. E is always just E, and then you're going to raise that to R times T. Now remember, R here was given as a percent. We have to change it to a decimal. Dividing 3 by 100 gives you 0.03. That's what 3% is as a decimal. So that's going to be raised to the 0.03 times 12 years. And then once again, you plug this into your calculator. And it's going to give us some kind of a decimal approximation. And I believe, assuming that we did this right, it is $1,030.42. That is not actually very good when you think about it. It takes 12 years for us to accumulate $30.42 with a 3% interest rate. Not exceptionally good. All right, where this formula is going to be really helpful, like I said, we'll do more of it in the next section, but let's say, for example, that we want to figure out how long it's going to take to triple or double or quadruple or something like that our investment. So again, we're going to start off with the equation A equals P E to the RT. We're trying to find out how long it takes. So it's the time required to double or triple an investment. We're going to try both of them just to see what happens. So if we want to figure out how long it's going to take to double the investment. If I want to double my investment, I don't actually even have to know what the investment is, but I definitely need to know what the rate is. So we're going to say that our rate, because that has to be given to us, is 5%. So we'll go with a rate of 5%. The reason I don't need to know what the investment is because of this. I'm going to show you this real quick, and hopefully this makes sense. Let's say, again, we invested $1,000 as our principal. Then we would have E to the 0.05 times T. Don't know T, that's what we're solving for. If I want to double the investment, that means I should get out 2,000. Well, when I try and solve this thing, I have to divide by the coefficient because we're now solving for t, which is in the exponent of the exponential. So this is where the whole stuff from the previous few chapters comes in. If we divide both sides by 1,000, we get 2 equals e to the 0.05 t. Well, let's say instead we wanted to invest $6,000. E to the 0.05 t. If we invest $6,000, that means if I want to double my investment, that's $12,000 as a return. Well, when I divide 6,000 on both sides, I end up with 2 equals e to the 0.05 t. So hopefully what you can see there is that it doesn't matter what the initial investment is. Once I do the division, I'm going to end up with exactly the same equation no matter what the investment is. 2 equals whatever's on the right side of the equation. So you don't have to know the initial investment. It's going to take the same amount of time to double it regardless of what your actual investment is. So if I want to double my investment given a 5% rate, the equation is 2 equals e to the 0.05 t. And if that doesn't really make sense to you, just pick a value. Pick a value for p, double it on the left side, you're going to end up with this equation anyway. All right, the question now is, how do I solve this? This is what we got from the last few chapters. I have an exponential. The idea is I want to change it into a log. The base of this exponential is e, so using a natural log makes the most sense since the base is e. So what we're going to do is you can do this in one of two ways. You can actually just change it into a log, or we can do what we did in the last problem of solving those logs, where we took the log or the natural log of both sides of the equation, which in all honesty is what you're probably going to do more than anything else. So let's try and practice it that way. We'll take the natural log of both sides. Using properties of logs, I can now bring the exponent out to the front of the natural log on the right-hand side of the equation. The left side stays the natural log of 2. On the right side, I get 0.05t times the natural log of e. The natural log of e is one of those that you're just going to need to start memorizing. The natural log of e is 1. Because technically the base here is e, so e to some power has to give you e. The power would have to be 1. So the natural log of e being 1 basically goes away because I'm going to have 0.05t times 1. So what that leaves us with is the natural log of 2 equals 0.05t. And then to solve for t, you just divide the whole thing by 0.05, excuse me. So we're going to get the natural log of 2 divided by 0.05. That's how much time it will take to double the investment. That doesn't mean anything to most people. This is where you use the calculator. You plug that stuff into your calculator. The natural log of 2 divided by 0.05 ends up being 13.86. This is in years. So it will take a little bit under 14 years in order for me to double my investment with a 5% interest rate. If I want to triple my investment, you may have already guessed it. Instead, on the left-hand side of 2, I'm going to have a 3. So part B, we'll say triple the investment. So we'll have 3 equals e to the 0.05t. Natural log both sides. Bring the 0.05t out to the front of the natural log using properties of natural logs. Once again, the natural log of e is 1, so now we have the natural log of 3 equals 0.05t, technically times 1. We don't need to write the times 1. Divide by 0.05, and we get that t is the natural, natural log of 3 divided by 0.05, and then get a decimal approximation for that, because again, that doesn't mean anything to anybody. And that's going to be 21.0 97, and again, that is in years. So it's going to take almost 22 years to triple your investment using a 5% interest rate. It's going to take a while. Again, this process is going to have a lot of application in the next section. So we'll come back and I will do, I think it's 7.8, and that'll be the last one for Unit 7.